All right, let's take a look at this one. So I can't make it do much closer without it totally changing the view on this. But we can look at this one. And you guys should have it on your paper anyway, so it's all good. So, I still don't have it. Okay. Boop. All right, I'll scan that in. So we're given these equations, and we're asked a whole lot of information. So we have 3 different equations for Malcolm's dive into the swimming pool. So just to give us a visualization, here's the pool. We know it's going to be that he has his little diving board here, and he's going to jump, and then he's going to splash. That's kind of what we know about this. So if we're looking at these equations and we want to know where our y-intercept is, where would we find that in our equations? All right, I'm going to get rid of this. That was not the eraser. Get rid of that wall. So this was our... Where do we get the y-intercept from? It's our c. So up here, what number is that going to be? This 16. It's in our standard form. It's this guy over here. So our 16, what is that? Y-intercept in terms of the story. How high you jump from? It's the height of the diving board. It's this guy. This would be our y-intercept on the graph. So it's at 16 up here. So our ordered pair is 0, 16. That's our y-intercepts ordered pair. There's a trash 16 over here. I'm just going to rewrite that. This is at 16. Boop. So that is how high he is when he begins his dive. That is the height of the diving board. He is at 16 feet. What are the zeros of the equations? Where are we going to find zeros? I was going to say, we can look at the factors, right? So we have factored form here, so we don't actually have to do the work ourselves. Yeah. This guy right here, and remember that our factored form is always that x minus our roots, like this. So our roots, our zeros are going to happen at 4, 0. That's the first one because it uses that opposite sign here. And our second one is going to be that -2, 0. What is that in the story? Like if I look at my picture over here, where is that going to be? Where in here? Yeah, it's going to be part of the lines pointing down. Slightly more specific. Because our water is the surface. So 4, 0 is this guy right here. -2, 0 would be back here. It's those x-intercepts, right? So those x-intercepts, the zeros, the roots, the solutions, those guys. And what they are, it's when he hits the water, when he gets to the water surface. When he hits, enters, gets to, whatever word you want to do, when he hits the water. How about, where's our vertex? Where do we get our vertex from? Vertex form. So that'll be this guy over here that we didn't use yet. So what is our vertex? 118. Then you gotta say it louder. I'm old, and when you whisper, I can't hear you all that good. Okay? So this is coming from our vertex form, and we have our ax minus h squared plus k. Our vertex is always at the point h comma k. Every single time. If we can find h and k, we are good to go. So when does he reach the peak of his dive? What time? One second. Yes, it's the x value of the vertex. 1 second. That's our time. The way we can know is x is time in seconds. 1 second. And how high does he go? 18, what? 18 feet. So it's all about finding the pieces in the story and in the equations here. We didn't actually have to do any calculations on it. We just have to be able to find the pieces. Okay, questions on this one? What else do you guys want to do? Number 6. Anyone need more time on this one? Because I got to clear it to be able to change it. All right. 3, 2, 1. All right. Then we're on number 6. Boop. Very similar, but we got to do all the work this time. We don't give you all the other equations. There we go. So we have here minus x squared plus 4x plus 5. And we ask you lots of pieces, and we're going to find a whole bunch of stuff. There's a whole lot going on here. So, first thing we're asked is, what is our y-intercept of this graph? Yeah, our y-intercept we're getting from our c value. This is in standard form, so we're right here. So it's just this guy right there. So our y-intercept is going to be at 0, 5. That's where our y-intercept comes from. So is this concave up or opening up, smiley facey? Or is this concave down, frowny facey? Why? Because we've got this negative leading coefficient. Yes. So it opens down. That's all that concave means, is that it opens up, opens down. Concave means opens in this case, because A is negative. That's how we know. So for our part C here, we were supposed to write it in factored form. There's a tricksy trick on this one. Because we have that negative A value, when we factor, we really don't want to have a negative in the A value, because it makes things super duper icky sign-wise. So I'm going to do my factoring over here kind of in the margin just so that we can see it. So when we're factoring, we're going to use the x and the box. But since we have our minus x squared plus 4x plus 5, and I'd really rather it not have that minus sign out in front, what I'm going to do is I'm going to factor out a negative 1. That's going to leave us with an x squared minus 4x minus 5. That gives us a positive A value, which is something way easier to factor. Please do not try and factor with minus signs in your A value. It is obnoxious to get all the signs on everything right that way. So pull our negative A value out and move on with our lives elsewhere. So when we're doing our factoring, we're going to factor this guy. That's when we take our A times C at the top. So I'm taking my 1 times the minus 5 to get a minus 5. Our B is that minus 4. We want to try and find a pair of numbers that multiplies to make negative 5, adds to make negative 4. What pair of numbers multiplies to make negative 5 and adds to make negative 4? Yeah, so we're going to need a 5 and a 1. Which one of those needs to be negative? Negative 5 in order for us to add to that negative 4. When we're filling in the box, we're going to take the x squared from this statement, our minus 5 from here. And then our two other pieces, the piece that we use the x frame for is to figure out how to split that middle term. So we're going to have our minus 5x, they get one of these, and my positive 1x. So then what we need to do is pull out our factors. What are we going to get as factors with my x squared and my 1x? Just an x. How about what do I get shared between minus 5x and minus 5? Minus 5. Top row, x squared and minus 5x. On this top row? X. Oop. Oh, I guess I got my purple left. There we go, x. And my bottom row, 1x and minus 5. 1, good. So our factored form, these are our factors on the sides over here. So our factors include our x, oh, why did the x do that? There we go. Our x minus 5 and our x plus 1. But we also need to include that a that we pulled out, this guy over here, our minus 1 is that a value out in front. So this is our factored form. Whoa, that's not what I meant. What's that?
Will we still be able to do this with the quadratic?
You could, to get your roots, to get it into factored form, you would need to then do your x minus whatever roots you get. Okay, because quadratic formula gives you this answer, not your factored form. So it gives you your roots. So that works. You could totally do quadratic formula, find your roots, and then build your factored form. Absolutely valid. But that's the order it would have to go in to do it with quadratic. Because what are our roots of this? What's the root we get from this piece right here, our x minus 5? 5. So we're going to have a root at 5 comma 0. And where's our other one? Negative 1, 0. So that's how we get it into factored form. Questions on factored form? Vertex form is a little bit different. Vertex form is where we're going to need our x equals minus b over 2a, that guy. That formula will be on the test. We're going to use that to be able to put it into vertex form. Thank you, dear. So we're going to go back to our original equation, back to this guy up here. When we have our y equals that minus x squared plus 4x plus 5. This gives us our a, b, and c right here. We have our a that's 1, our b that's 4. That's our b. Oof. Come on, there we go, b. And then our c is that 5. That's what we use to get that y-intercept. So when we're trying to figure out our vertex form, we're going to take those values. Our x equals the opposite of our b, and our b is 4 over 2 times our a, and our a is negative 1. So we get negative 4 over 2 times negative 1, or negative 4 over negative 2. What is negative 4 divided by negative 2? 2. So that gives me the x of my vertex. That is the x value of my vertex. To get the y value for my vertex, plug und chug. Thank you, dear. Plug and chug. So we're going to go back into our original equation, and I'm going to say what happens if x is 2. So we're going to substitute into our y equals minus 2 squared plus 4 times 2 plus 5. So we're substituting this 2, this x of 2, in place of all the x's. And we can type that in the calculator. Don't forget the minus sign that's out front over here. What do we get when we substitute those pieces in and evaluate that? What is minus 2 squared plus 4 times 2 plus 5? Nope, should not be negative 3. You said negative 3? Should not be negative 4. It's okay. 9.
Oh.
Should be 9.
Yeah, that's what you were talking about, not the.
Oh, no, I was doing the whole thing.
Oh, yeah.
No, yeah, okay, totally fine, yeah. Negative 4 plus 8 plus 5, absolutely valid. Totally fine. We were just communicating in a different way. We were both speaking different sentences. Gotcha. We're back together now. We got negative 4 plus 8 plus 5, and we get that our y value is 9. So that gives us our h and our k. We now have our vertex. We know our a. We've used it twice before. That was our GCF in our factored form, and it was how we knew that our graph was concave down. So we can write our vertex form since we know that our y is going to equal that a of negative 1, x minus our h, so x minus 2 squared plus k plus 9. And I know it's super crowded, but I have a chunky pen. Okay. Good questions, good questions. And what else do you want to look at? Shaving a haircutting my door. Thanks, Barry. Number 4. There we go. Hello, hello. Awesome. Okay. Oh, it's past this time. Sweet. Christy. Nope. Nope. All right. So we said, so it was 4?
Yeah.
4. Okay. Let me clear this because I got to scroll it. Boop. Number 4. 2. 4. Oh yeah, these are good ones. B. B is a great one. And it's a very similar vibe to A. So great practice for both of those. I'm going to zoom this in just a smidge because we don't need that much. There we go. Yay, we can use things with actual size words. Those long problems are great, but sometimes they're just too long. All right, so we are going to look at this one. We are going to try and write the equation when we're given this information.
Where's this 2?
That is a wonderful question.
Let me see it.
I can't read cursor.
Green? Miss Green, I think?
Is she the person who's
She's at the front desk. Yeah.
Okay, then yeah, I do know who that is.
Oh, no, this is guidance. She's one of the guidance secretaries. So go to the guidance office.
Got
Valid question though, because I'm looking at that too going, I don't really know. Okay. So what we have here on B for number 4 is we have a couple of points. Actually, 3 points. What do we notice about these 3 points? Yeah, we've got some intercepts. I've got the y-intercept here. This is our y-intercept. And these two are both x-intercepts. X-intercepts are also known as our roots, right? So that means I have access to both of my roots plus 1 point. So if we know both of our roots, we can get ourselves a factored form equation. Because to start our factored form, we use the 2 roots. So our kind of generic version of factored form, that's our y equals a x minus r and x minus s. Those are both roots. It's just different letters, so we see that they're different. But we know 2 of our roots. I know we have a root at -2, so I can put that in place of an r. And we have a root at 7, so I can put that in place of the s. So we can get a first bit of this. Y equals a x minus -2 and x minus 7. What do we notice about that one right there? What can we fix at this point?
2x plus.
Yeah, x minus -2 is gross. We don't usually like to have double signs right there, so x minus -2 is the same thing as having x plus 2. So that's a start. So now we've got our roots in there, but I still have 3 variables. 3 variables is not good. I need to be able to solve one of those down. What do we have that can help us narrow that in? Because I would love to be able to find our a. We have another point. So if I want to be able to figure out what this a value is, what we're going to do is we're going to take the other point we didn't use, the not x-intercept, and we're going to sub this in to find a. So we're going to take a little detour. I'm going to say, all right, I know that my y is going to be -42 with a, we don't know it yet, but I can substitute in that 0 for x, so we're going to have 0 plus 2, and I can substitute 0 for x again, 0 minus 7. So I'm substituting those 2 pieces in, my 0 and my -42. Now I have only one letter, and I can figure out what a is. So we're going to simplify this a bit. We've got our -42 equals our a times 0 plus 2 is 2, and 0 minus 7 is -7. So we're going to simplify those guys. What else can we do over here? Say it again.
Multiply 2 times -7.
Yeah, multiply the 2 and the -7. So we get -42 equals a times -14. Remember that it's times, it doesn't magically turn into subtraction. What can we do now? Divide by that -14. So what is the value of a? 3. So that means we know our a is going to be 3. Everything else is still the same. We still have our x minus -2, which is x plus 2. We still have our x minus 7. In our forms, when we're asked to write an equation, we should still have both x and y in it, but we should not have any other letters. So when we're asked to find these equations, our we need to have everything figured out except for the x and the y. Those should both be there. But we need to have a, we need to have h, we need to have k, we need to have our roots, we need to have whatever other pieces we need for the form. Only letters allowed left are x and y. But we can use those pieces to find our other pieces. Okay? Just kind of hoping one of us asked that question because those ones are tricksy sometimes. Any more that we want to go through?
Three.
You said 3? 3? Okay. Ink. Let's look at 3. Oh yes, this is a good one. All right. It's gonna be a little tricksy because I only have limited screen space, but we can still talk through some things here. So, what we have here is we have some graphs, and we're trying to figure out which of these equations are going to go with which graph. So, I'm just going to keep it up here. Okay, fine. Whatevs. And so, we've got our graph A, and our graph B, and our graph C, and our graph D. And down below, we have our list of 4 equations. What do we notice either about our equations or about our graphs? Let's see, I'm going to zoom this out so maybe we can see everything. There we go. What do we notice?
There's graphs.
There's graphs. We're not wrong. Slightly more specificity, please. I'm good at words. Specificity. What do we notice about our 4 graphs and our 4 equations?
They're all parabolas.
There's 2 that open up and 2 that open down. So right now we can tell a little bit about which equations are going to go with which ones. So we have 4 different equations. Which ones are going to go with the graphs that open upwards? The ones that have our positive a value. So in this case, that's going to be C and D for the equations. Lowercase c, lowercase d. And our graphs that are going to go with our upside downies, our frowny face graphs, are going to be the first 2. So I'm going to zoom this back in. So let's look at those first 2 graphs and those upside downy parabolas, just so we can look at everybody at the same time. So we know that these 2 are going to go with these 2 because of these negative a values. We love that. How can I tell which one's going to go with which from here?
C is like, because the root is, what the root is -6.
This is going to go with graph C because we have a root. There we go, 2 O's. At -6, 0. That's this guy. This one has a root at +6. So we know it's not going to be this guy. This guy does not have a root at -6. So we know it's going to go with graph D over here for equation B. But how could we tell here? What else do we know from this?
Negative.
It's negative, so we know it's frowny face, and we've already used one of them, so process of elimination. What else do we notice about this one?
It's thicker.
He's thick. It's almost like somebody sat on it. It's been squished. It's so little and cute because it's been compressed. This one has an A value that's really little. This has been compressed. And we can tell that because this one doesn't go up as high. This one has its maximum right around 4.5. This one goes all the way up to about 9. So it's shorter. So we know it's been compressed. So that's one way we can tell about that one. So then we could look at our positive equations. So this one here, but now I can't zoom back up. So our two positive equations, we have a couple of very similar pieces. But what do we notice about those two equations?
They're positive.
They are both positive. Not wrong. That means we are going to have graphs A and B that go with them.
They both start at the same point for y.
They both have the same y-intercept, so that's not going to help me super lots.
They both have an x root at 0.
They both have a root at 0. That's our y-intercept. Truth. So we've got a lot of things so far that aren't helping. What's something that will help?
One's positive, one's negative. When it comes to the root of 6.
I was going to say, we've got one that's in factored form, right? Because we've got equation D. I just don't have it up here on my screen. Just because I didn't want us to have to zoom all the way. So D has the equation of x times x minus 6. And C is this one down here at the very, very bottom. We've got C. That one's C right here. So what do we know based off of these pieces of information? What form is this one in on lowercase c? What form is that equation? Yellow. Vertex form. So this one has a vertex. Where? Where's our vertex? -3, -9. So if we look at our graphs, which one of these graphs has a vertex at -3, -9? A. -3, -9 is this guy right here. That's our vertex. So we then know that equation lowercase d goes with graph, which one? B. And the reason we know that is we have a root at 0 here, and we have a root at 6, which is this guy over here. So we're just kind of finding our pieces. A lot of times we'll be given either just like a dot here or something like that. It won't necessarily always have the full numbers, but we have a lot of information we can get just from looking at those pictures and those equations. Probably have time for one more, if we want to do one more question. 14. A quadratic formula is probably a great choice. Clear some ink. There we go. Boop, boop, boop. Scrolly, scrolly, scrolly. There we go. Let's see which one do I want to do. Let's do A. And then I'll leave you guys B to do. I'm going to zoom it in just a little bit more, and I'll just write the blanks myself. All right, so we're supposed to use the quadratic formula. There we go. I'm just going to put it right there. That way we can have our stuff. That way we have our quadratic formula up here, and we've got our equation. So quadratic formula is over here. We're supposed to get our radical form. We're supposed to get our decimal form. But what do we need to do very, very first step before I can just start plugging and chugging over here? I have something I have to do first. Because whenever we're doing quadratic formula or factoring, what do we need to do first? Is the very, very first step. Equal to 0. It has to be equal to 0. So in order to get this thing to equal 0, what we're going to do is subtract our 5x from both sides. That's going to give us our 0 equals 2x squared. if we think of it, you can go ahead and put our minus 5x in the middle just so that we have everything in the right order. But you can also tuck it on the end if we don't notice that. But what's really important for us to notice is that we have our A, our B, and our C. It doesn't matter if we tuck the 5x at the end, that minus 5 goes with the x, so that makes it a B term. So our A here equals the 2. Our B is the minus 5. And our C is the minus 12. Those are the pieces we're using to fill in our quadratic formula. So then we're going to have our x equals, and we can start filling in pieces. Opposite of B plus or minus square root B squared minus 4 times A times C over 2A. So it should look like this fully filled in, but this is a mess and really difficult to type into a calculator. So that's when we want to find the value of the discriminant. The discriminant is this guy underneath, not including the square root, just the stuff underneath. And if we simplify that bit, that's going to give us the square root that goes over here. What is negative 5 squared minus 4 times 2 times negative 12? The under the radical bit. What will we get there for this guy? Doing it in orange. $121. So we have, by doing some simplifying, our minus negative 5 gives us a positive 5. Square root of 121 over 4. I would 100% take that for our radical form. We are going to get how many roots on this? How many solutions are we going to have? 2, because we have this plus or minus. The only way we're going to get 1 is if this guy is 0. We should not wind up with imaginaries. So we're going to split this and get our 2 decimal form answers. So we're going to have our x equals 5 plus, what is square root of 121? 11 over 4. And we're going to need to do our 5 minus 11 over 4. Well, 5 plus 11, that's 16. And 16 over 4 is 4. 5 minus 11, that gives us a negative 6 over 4, which is going to be fractiony, so it's negative 3/2 or minus 1.5. That is also fine for our decimal form. Okay, so when we ask you for both the radical form and the decimal form, that would be, this guy was our radical form, these guys are our decimal forms. Okay, I will get the whole answer key with all my work and stuff posted up here momentarily. I just got it finished uploading. But that way you'll have it. Have a great rest of your day. See you tomorrow.